The production function is a relationship between the quantity of inputs used to make a good and the quantity of output of that good. The production function gets flatter as production rises. So let's look at an example here. We have Farmer Jack growing wheat. He has 5 acres of land, and the land is a fixed resource. He can hire as many workers as he wants. The quantity of output produced varies with the number of workers that he's going to hire. So if he has 0 workers, obviously 0 output. 1 worker will give him 1,000 bushels of wheat. 2 workers, 1,800. 3 workers, 2,400. And 4 workers, 2,800. 5 workers will give him 3,000 bushels of wheat. So as you can see, as he hires a larger number of workers, the output of wheat that he's going to be able to harvest increases. The marginal output looks at the increase in output that arises from an additional unit of input. All other inputs are constant. Marginal product of labor is calculated as the change in quantity over the change in labor. If Jack hires 1 more worker, his output rises by the marginal product of labor. So in our previous example, when Jack goes from 0 to 1 worker, his marginal product of labor is 1,000. When he goes from 1 to 2, it's 800. 2 to 3, 600. 3 to 4, 400. And 4 to 5, 200. Marginal product of labor is going to fall over time. We define diminishing marginal product as the marginal product of an input declines as the quantity of the input increases. The production function is going to get flatter as more inputs are used and your output is increasing. The slope of the production function is going to decrease. So notice that the marginal production of labor equals the slope of the production function. Marginal product of labor is going to fall as labor increases. This explains why the production function gets flatter as the amount of labor that you're hiring increases. So if you hire your first worker, your marginal product of labor is 1,000, second worker 800, 600, 400, and 200. And along with that, the production function is getting flatter. So why is marginal product of labor important? Rational people think at the margin. It's one of our basic economic concepts from the very first chapter. When Farmer Jack decides to hire another worker, he's going to have to pay those workers a wage. His output will rise, so Jack needs to compare the increase in output to whether or not he should hire that worker based on the cost that he's going to incur to hire that additional worker. Farmer Jack's output rises by a smaller and smaller amount for each additional worker. Why? Because as Jack adds workers, the average worker has less land to work with and will be less productive. In general, marginal product of labor diminishes as labor rises, whether the fixed input is land or capital. And remember, capital refers to equipment or machines. So in this example, Farmer Jack must pay $1,000 per month for the land regardless of how much wheat he decides to grow. The market wage for a farm worker is $2,000. So Farmer Jack's costs are related to how much wheat he produces. So the cost of the land is fixed, doesn't change. The cost of the labor, of course, is going to go up as you hire more workers. Your total cost is also going to rise as you hire more workers. So in the example, we can graph Jack's total cost curve. and that cost curve increases as more workers are hired. So this shows as the quantity of bushels that are going to be harvested increase, the total cost is going up as you're going to have to hire more workers. And marginal cost is the change in your total cost as you add or hire an additional worker. So marginal cost usually rises as your quantity rises, as in this previous example. And again, here's the graph of marginal cost. Why is marginal cost important? Farmer Jack is rational and he wants to maximize his profit. To maximize or to increase his profit, should he produce more or less wheat? Farmer Jack needs to think at the margin. He needs to consider the cost of additional wheat, the marginal cost. Is that less than the revenue he would get from selling it? Then Jack's profits rise if he produces more wheat. Costs can be categorized as fixed and variable. Fixed costs do not vary with the quantity of the output produced. For Farmer Jack, his fixed costs refer to the land. The land cost him $1,000. Other examples of fixed costs are equipment, loan payments, rent. Variable costs vary with the quantity of output produced. For Farmer Jack, variable costs refer to the wages he pays his worker. Other examples would be the cost of materials. So total costs equal fixed costs plus your variable costs. Our second example is more general and applies to any type of firm producing any good with any type of inputs. Calculate and graph total costs, knowing fixed costs and variable costs. Calculate and graph marginal and average costs. Understand the relationship between marginal costs and average costs. So here, fixed costs are 100, and those are graphed as horizontal. Variable costs are going up, and there's your variable cost curve shown in red. And then total costs are going to be increasing as well, and the total costs are shown in green. Recall that marginal cost is the change in total cost from producing one more unit. So here, your marginal cost from going from 0 to 1 is 70, and then so on and all the way up to 140. Usually marginal cost rises as your quantity rises due to diminishing marginal product. Sometimes, however, as here, marginal cost is going to fall before it rises. And that's what's happening here. So marginal cost is going down before it starts to go up again when you produce 4 units. So here's the marginal cost curve again being graphed, and as you can see, the marginal costs are going down before they rise. Average fixed costs are fixed costs divided by your quantity of output. Notice that average fixed costs fall as your quantity rises. The firm is spreading its fixed costs over a larger number of units. So you see here, as fixed costs are graphed, that graph shows fixed costs falling as more units are produced. Average variable cost takes variable cost divided by the quantity of output. As your quantity rises, your average variable costs are going to fall initially, but in most cases, average variable costs are eventually going to rise as your output rises. And here, the graph shows average variable costs falling, and then on the right side of the graph, they begin to rise. This chart shows average total cost equaling total cost divided by the quantity of output. Also, average total cost equals your average fixed cost plus average variable cost. Usually, as in this example, your average total cost is going to be U-shaped. So as the quantity rises, initially your average fixed costs pull down your average variable cost, but then eventually your variable costs are going to go up, and that's going to drive your average total cost to also go up. Here are all of the various cost curves together on one graph. Average total in green, average variable in blue, the more of a royal blue, average fixed costs in dark blue, and your marginal costs in red. So here, when your marginal cost is less than your average total cost is falling. When your marginal cost is greater than your average total cost, your average total cost is rising. The marginal cost curve crosses the average total cost curve at the average total cost curve minimum. For this active learning activity, I would like you to fill in the various costs in the chart where they are blank, applying the relationships that were presented in this video.